welcome to the first episode of the Cloud Cadet podcast, a podcast brought to you by linuxacademy.com. And in this podcast, our goal is to provide you with some good how-tos, talk about some of the current cloud and Linux technologies being run in the cloud, and actually just help you run some of your cloud. So with that, my name is Anthony. I will be a co-host for this show every once in a while, and we have Christoph, who's also co-hosting today. Christoph, can you tell us a little bit about yourself real quick?
Yeah, so my name is Christoph Limpelaar, and I actually just joined Linux Academy a few weeks ago, so I'm getting settled here, working on a few courses, so really excited to release some of those.
And if you don't know, there's another podcast that Christoph does called Scale Your Code at scaleyourcode.com. Now, tell us a little bit about what you do there, Christoph.
Sure, so I interview all kinds of different people. I've interviewed people from Google, from TwitPic, Netflix, that sort of thing, and we talk about large-scale systems, web performance, and we also try to sprinkle in some web security in there from industry experts. So it's a lot of fun.
Yeah, it's a really good podcast. You do a great job on that. And so with us today, we have our guest. So what we're going to be doing at each one of our shows is we're going to be having a guest, and it's going to be an instructor that's been working on some content for linuxacademy.com. And with this, he's going to talk about what he's been doing, kind of the goal behind the course, as well as do a really cool demo and teach us how to do something. So this is something where you're going to get a lot of good knowledge. And I think you're going to be particularly interested today if you like Amazon Web Services and you like Ansible. So say hello, Instructor Terry, and tell us what you're going to be doing today.
Hey, everybody. This is Terry. For those of you who don't recognize my voice, I've been on Linux Academy in one form or another, part-time and now full-time, for about 3 years now. So I've been around a bit. We're going to talk about Ansible and using Ansible with AWS today. We'll walk through a quick demo about how we would instantiate an Ec2 image, and then kind of talk through some of the environment setup that you have to go through if you're going to use Ansible with AWS. And then once that image is instantiated and we have a running instance, we're going to use another playbook that's more indicative of something you might see in an enterprise, for example. We'll connect to it. We'll make some changes to it, deploy a simple website, and then we're going to turn that into a template, creating an AMI from that, all within the playbook, and then we can reuse the first playbook to launch further instances from it.
Now, is this a course that's more for beginners, or is it advanced level, or both of them?
I would say that it's an intermediate course. It's not an Ansible course in that we're not going to be teaching Ansible from scratch, nor are we going to be teaching AWS from scratch. So certainly some background with each of those is going to make this something that you can get the most out of. And we do give you the course names inside the Ansible AWS course for those people who may want more information on it.
And you're also the instructor of our complete course on linuxacademy.com of, what's the name of that? Ansible? Learning Ansible?
Configuration management and deployment with Ansible. Yes, I am.
Gotcha. All right, so all three of us here are actually AWS instructors, so I have a feeling there might be a little bit of extra commentary randomly when we interrupt. So this could be a pretty cool first episode. Christoph, are you ready for Terry to get started?
Yeah, let's do it.
Terry, you ready to get started?
I'm connected to my lab server and have my web browser up.
Fantastic. Why don't you go ahead and show your screen, and we'll make sure that it is appearing for everyone.
All right, so when using Ansible, for those of you who may not have had a chance to take the full Ansible course, Ansible is what we call a YAML-based or an outline-based type of configuration file. And YAML being Python-based, it's often referred to as something that's an outline or a key pair base, whereas you have one item equaling another on one line at a time so that it looks like an outline. One of the reasons why it's really effective is because YAML is very portable and it's very easy to read for people who don't have a programming background. It's one of the things that I think makes Ansible very popular as well as very powerful. So what we have here is we have an Ansible environment set up. And again, we're not going to obviously go through the entire Ansible setup, but we have an Ansible version of 2.1, which is the latest development version. I will have to give a caveat in working with AWS in that Ansible and AWS right now have one bug that they're currently working through, which is normally you would be able to share your credentials for your security keys through environment variables, but there is a bug in the to branch that they're currently working through. I've been working with their development team in figuring out what it is, and we think it's actually a minor version of the Bodo plugin for Python, but we're still working through that. So I'll talk about what that means when we develop our actual playbook. One of the first things that we want to do is if we go over here to our Amazon Web Services console, we're going to be working with Ec2. Ec2, there's probably 25 different modules that are available for Ansible dealing with Ec2 in some version, whether it's working with the AMI or grabbing information about Ec2 instances, launching, running their state, etc. So we have several instances here, but what we want to do with our Ansible playbook is we want to launch an Ec2 instance that we can use later on. Fortunately, that's pretty easy for us to do, and I've got a what we call a YAML playbook already developed called the demo provision. So let's take a look at that YAML file. If we edit that file, I'll walk through what these settings are. Up at the top, it tells us that we need to connect to our local host. And the reason that we're connecting to localhost is because all of the AWS configuration information is on what I call my control server, which is the server we're on now. We're using a local connection versus an SSH connection. There's two types of connections that you can use for Ansible, whether they're local or SSH. The user that we want to use remotely to connect, so those are the credentials that we'll use for our remote user called test. Become unless you know what it is, it doesn't make a lot of sense, but it means we're going to run a sudo. We want to become the sudo user. Gathering facts for our local host. Fact gathering for Ansible is just a way to get a whole bunch of environmental information, things that we can use from within our playbook if we want to. And then we're going to include some file variables. We have two files that we're going to include, one of which includes our AWS credentials, and that's kind of working around the bug that I mentioned earlier. And then we've got some information in another file that allows us to import some variables.
So what we're going to do here is, I interrupted Terry, and we're going to ask him a quick question. So he has the AWS access key and secret access keys configured in there. So what I think he's doing is, correct me if I'm wrong, Terry, is I think you're going to be passing it AWS security and access keys, correct?
Yep. We can see that if we go back over here to our AWS console, and we go to our security settings. So security credentials are something that are necessary for us to be able to work with AWS. It's in the identity and access management. So if we go to the users, we've created a couple of users, one of which called Ansible, one of which called test. And we've generated these keys, these security credentials that allow us to interact with the AWS console. And then we, of course, had to grant them the appropriate permissions for dealing with or working within our console. We gave them a particular role, whether it was an admin role or EC2 power user role, etc. And, of course, we don't see what those security credential keys are. We see the key ID, but the only time that you can get the actual secret key is when you create the credential. And then if you don't have that, then you have to either delete or make inactive and recreate your access keys. But that's exactly what I'm doing.
Now, usually when you have these credentials, you can set them locally on your machine, right? Mm-hmm. But you're saying there's a bug with that. Is that where the bug comes in? Is that where you have to pass it in as a file?
So if we go out here, normally what we would do is we would set in our profile, we would set a couple of environment variables that give us our access keys. And I'll deactivate these keys, obviously, afterwards. But these keys would allow us to just run our EC2 module. But right now, there's a Python bug related to the 2.x branch, which I need because that's where most of the AWS modules are in core, that does not import correctly those access and secret keys. So what we're doing instead is we have a file in the files directory. I've created a YAML file called AWS creds that has my AWS key ID and region that I import into my file, and then I pass into the module that I'm trying to run AWS commands against.
Now, my quick question is the reason, and we want to clarify this because of AWS security best practices. So we know that AWS security best practices don't use API access key and secret access keys if you're going to be running it from, for example, an Ec2 instance. So the reason that you're using them is because you're actually running Ansible from a linuxacademy.com lab server, which is outside of your AWS account. So if you were running this on an EC2 instance, we wouldn't necessarily have to pass it the API access keys, or we would.
Well, we would still need to pass the access keys because that's what allows it to interact with the APIs that control the AWS services. So yeah, we would still need to set up access even if we were running on an EC2 instance. Because we're talking about the difference between the AWS key for the API versus the PEM key that we would need to connect as the EC2 user to that instance.
So you're using Ansible to deploy this out. And we know that when we're using the AWS SDKs, if you're running the code from an EC2 instance and you're using an SDK, the SDK is actually pulling from the instance metadata temporary credentials that are assigned to the EC2 role. Now, since you're not using a specific SDK yet, and you're not even on an EC2 instance, you're just grabbing the API keys so we can be executing it outside of the AWS environment. So this is a good example. If somebody was, for example, using or doing what you're doing to deploy EC2 resources from their local machine, not from an EC2 instance within their AWS account, correct?
That's exactly correct, and it's not uncommon for what you would call your control server to be outside of your Amazon environment. That's where all of your playbooks are going to generally be stored, and it's generally a good idea to have your playbooks, if not checked into a Git repository, at least your control node be outside of EC2. But absolutely, you could run this on an EC2 instance using the temporary credentials created in the role.
Okay, fantastic. I just wanted to clear that up.
In our case, because we're running on a Linux Academy lab server, we would normally be able to do it as part of an environment variables, but there, like I said, there's a bug. Hopefully by the time you're viewing this, it'll be addressed. They've actually addressed one other bug that I've reported. The Ansible team is really good about listening to feedback on their chat channels.
Fantastic.
All right, so we'll go back over here and we'll go back over to our EC2 instances just so that we're seeing what we're doing here. So we have a number of instances that are currently running, but I'm going to launch a new instance just using an Ansible playbook. All right, so let's go back in. Let's go to the files directory. I just want to show the couple of files. We looked at the AWS credentials, and there's another variable file that we created called info.yml. Now, this is one of the more powerful things about Ansible is the layer of abstraction that you can have so that it allows you to reuse playbooks as either roles or just abstract playbooks that can change simply by changing the value of a variable in a file. So we've defined a number of different variables that we would want to use. The AMI that we would want to use if we're deploying a standard image, one for a web, one for a database, one for a file server. Right now they're all the same AMI, but we could absolutely define an AMI for each of those instances, and you'll see that a little bit later as we talk. We've got 3 different instance types that we can refer to just by changing a variable: tiny instance, free instance, large instance. We've got our SSH key name because that's necessary when we associate an instance with a key name so that we can actually log in. And then we're going to have an instance ID and a template ID, which will come into play later, and then a custom security group, which will allow ports 22, 80, and 443 into my instance.
Now, is that SSH key name? That's not creating the key. That key already has to be created inside of EC2. Is that correct?
In this case, yes, it does.
Okay.
How do you know that you need those? Is there a place you can check and that tells you, hey, these are required and these are optional?
The Ansible documentation for AWS is actually pretty comprehensive, and actually we can take a look at that. We can look at ansible.com, and then we'll go over to the documentation. And they just changed the website.
It looks like it's automation for everybody.
When actually all I want to do is go to the docs here. Here we go.
Oh, there we go.
So the module index is where you're going to spend most of your time, because the module index has broken all of the different modules we can use in Ansible playbooks out into various categories. Cloud will tell you, for example, you'll see the vast majority of modules for AWS is in the EC2 category. There's a ton of EC2 modules. We cover every one of these in our AWS Ansible course. We give you examples of playbooks that use them individually, and then we have use cases that show you how to kind of put them together. And that's kind of what we're going to be talking about today. But for example, on EC2, it will tell you not only what options are available, but whether they're required when you use that particular module or not. Not only in terms of just the Python version and any Python plugins, but any of the parameters that you'll see within our playbook. And it'll also give you, if you scroll down towards the bottom after this entire list, it gives you examples of certain types of module uses. So this is where this will be the first place that you'll check to be sure that you've got anything that's required in your playbook if you use this particular module. So if we edit the demo and provision, this is what we end up with. So we have these variable files included so that we can use those variables. And one of the ways that you make sure that you have reusability is through abstraction. And what I mean by that is I may right now be using this playbook to provision a basic Ec2 instance off of a particular AMI, standard image. But I may change that at some point in time. Now, I can either go through and edit one or more playbooks, changing the AMI ID in each one, or I import a variable file like this info.yml and change it in only one place. And then, of course, I can reference it by the variable name from within that list. So, for example, my access key and my secret key can change at any time based upon who's running this particular playbook based on the value of that variable that's included in my AWS credentials. Equally, my standard AMI, which in this case just happens to be the AMI for Amazon's Linux version, but my standard AMI could be defined as anything else, the same as my instance type. I'm using the free instance in order to keep costs down, so it's a T2 micro. I know from defining it in my info.yaml. I can launch multiple EC2 instances by simply upping the count from 1. I'm indicating that I want whatever I'm instantiating to be present. If it already exists, then it's not going to launch a new one. And the reason that we don't want to launch a new one is because we're going to assign a name to it. It's how I'm going to know what this particular instance is tagged with. So I'm going to tag it with a name called podcast template. And then I'm going to register. And this is a really useful variable, because registering means all the JSON output that tells me everything that's been done when I run this particular playbook will be loaded into this variable that I will print out with a debug command. So it'll tell me things like the IP address, the instance type, the DNS name, and more importantly, if in my case, it'll give me the instance ID, which I'll need for my next playbook. So this is a really basic way of just spinning up an EC2 instance. And one of the things that I recommend that most people do, if you're not going to do anything immediately after it, is make sure you indicate wait equal no, because otherwise it'll wait until the instance ID is completely set up and the first monitors have succeeded, which can take 3, 4, or 5 minutes where you're not going to get any feedback on your command line. Questions about that, and then I'll go ahead and run it.
No questions, but I do want to comment how easy it is to read. I really like the format of how Ansible is laid out. It's just so easy on the eyes.
The outline format is really great because you can tell what goes to what. The name goes to the task, EC2 goes to the name, and then the subkeys, each one, the indentation is great for readability.
Mm-hmm.
All right, so when we go to run an Ansible playbook, since we're not connecting to an EC2 instance, so we don't have to worry about our PEM key or SSH agent or anything like that right now. We're interacting directly with the AWS API to launch that instance from within our EC2 console. So all we have to do in this case is making sure that we're logged in as a user that has credentials configured in our info or our AWS credentials file, and we do Ansible playbook and just the name of the playbook, demo provision.yml. And each task will tell us as it executes what it's doing. Basic provisioning of EC2 instance, done. The debug task, and this is that EC2 info variable, and it tells us everything that we've done. Now this, for example, ending in 660 should then match the new EC2 instance. If I come over here to my Ansible console and go over here to refresh my Ansible instances, I now see a podcast template instance with the instance ID of 660, T2 micro, associated with the my latest key that we indicated, and using the security group that we indicated, and the rules that it allows in is 80, 22, and 443, exactly as we indicated in the playbook.
Now, did that security group exist before you launched it? Does it need to exist, or will it actually create it?
So there's a couple of ways to do it. The security group I applied here, I had already created. However, it will launch, if it's not indicated, with your default security group, which is created for you automatically for all Ec2 instances to use if you don't indicate what a security group is. Or in the earlier part of the playbook, we could have created a security group through a playbook and then got that security group ID and applied it to our instance. So there's 3 ways we could do it. Use the default, use a pre-created one, which we indicated in our files variable, or create one and then use one that you just created for this instance. In this instance, I had already had a pre-created one with allowing ports 80, 22, and 443, so I used that.
Very good, thank you.
Mm-hmm. So now I've got this instance and it's already up and running, and I can verify that I have access to it by adding my SSH agent and then SSH add for my key pair. This will allow me to connect using SSH and the EC2 user to the instance that I have. So my podcast,
without having to specify the PEM key each time, right? So since you just added that using, and for those following who, can you open that screen back up?
Sure can.
So it's a cool note that you can do this, and it's a lot of times missed a little bit. But so you can connect using SSH-I and specify the PEM key. But since you just did an SSH agent bash, what that does is it basically adds it to your current running bash session. It's almost kind of like a cache, and it allows you to just SSH directly without specifying the key. It'll always know to use that key. Is that right?
We'll take a look right now. We'll grab the IP address. It's attempting to log in. So exactly like Anthony described, what we did is we created a new bash instance that's running the SSH agent. So it's running on top of a bash instance. And by doing the add, we've added that credential key to that particular bash shell, that agent running on the bash shell. So therefore, that key is then now associated with this session. And you're right, I can just do an SSH to EC2-user, which is the standard SSH user for EC2 instances, to the IP address, and you can see that it's the Amazon Linux AMI.
Which, if you log out of the current bash shell, not the EC2 instance, but where you did the SSH and the TCOX one, if you log out of that, you will have to do your SSH agent SSH add again. It's just temporary for the life of the bash session.
You got it. So now we have this instance. We're running what we call a podcast template, but it's an EC2 instance. Now, what I might want to do, and what would be more normal, is you're going to execute some commands against this. And in this case, we're going to add the HTTP service, the Apache, to it. We're going to copy a file, an index file, that'll indicate that it's a part of this podcast demo. And we're going to enable and restart the service. And then what we're going to do is we're going to create an AMI, or we're actually going to turn it into a template that we can use to instantiate other web servers. So what I mean by this is, once I have a single node that's been prepared the way that I want for my configuration, I can easily turn it into a template that I can create an AMI from, so that I can instantiate further EC2 instances from it with all of those changes already reflected, so that I don't have to run complex playbooks 100 times if I need 100 nodes. I just launch 100 nodes that are pre-configured. Mm-hmm. So let's take a look at our demo template. So what the template's going to do is it's going to accomplish a couple of different things. The first thing that it's going to do is it's going to connect to the AWS instance. So we're going to need to add in an entry for that AWS instance in our Etsy Ansible host file. It tells us what hosts that we can connect to just by referring to them as a shortcut name, in this case, AWS. It's going to use, this is where we're actually going to use normal SSH commands to do installations through Ansible like it was any other node. other than the fact that it's using the EC2 user, and we have this PEM file that's associated with our bash shell, it's connecting to it like it would any other Ansible node. It doesn't make any difference that it happens to be at AWS. It's just a Linux node that I'm connecting to, and I'm going to run some commands against. So we're going to gather facts, connect over SSH, and the tasks that we're going to do, and this is Ansible-specific tasks, we're going to install Apache Web Server, which is the HTTPD package. State is the latest, meaning we're going to make sure that we install the latest version, even if an older version is already installed. We're going to copy a new index file from the files index.html source to var/www.html index.html, applying the appropriate user and group ownership. And if the file exists, by doing backup equal yes, then we'll back up that file in our home directory. And again, just like all of the cloud instances, if you go to the AWS documentation, you can see through any of the modules what we're doing. So file modules, for example, if we go over here to copy, it'll tell me that the copy module has these parameters that are available to us, and it'll give us some examples about how to use it.
Now, at what point during the startup process here is this executed? Is this kind of like bootstrapping? Is it using Cloud Init, or is this after everything is fired up that it's actually performing this task?
Well, in this case, the instance that we're connecting to is already fired up. We're going to actually add the instance that we just created here. We're going to add this IP to our configuration to connect to. So we're going to actually use that instance to create what is going to be a template for us to use in the future.
So this is doing what Ansible does. It's not necessarily taking advantage of the bootstrapping feature. What it's doing is since Ansible, instead of running an agent, Ansible basically connects via SSH. So of course, SSH will be started, and that's usually started after the Cloud Init script. And so it'll connect via SSH and perform these tasks. That's what's happening?
That's exactly what's happening in this first section up here.
And you specify the order of the tasks depending on how you lay them out and call them, right?
Correct. Now you can do some dependencies, meaning that we can indicate to do a particular task and then a follow-up task only if the first task executes. That's called handlers, but they're not programmatic handlers. They're pretty simple handlers. They either run or they don't. And there's no way to indicate that a handler can run conditionally unless the precursor needs to be run. In other words, I may go to install HTTPD. If it is already installed, Ansible will skip that particular item, and it won't call the handler. So it won't run the notify event. So for example, if I go to install this and I want to restart the HTTPD server as part of a notification event, that notification will only fire if I had to install or update the HTTPD server. If I didn't, then the notifier will be skipped because the step is skipped. So this is one of those instances where you may have multiple playbooks, one for updating an environment versus one for what Anthony said, bootstrapping an environment. Make sense?
Absolutely.
Sense,
Thank
yeah.
you.
So then we have a second section, which is actually doing something completely different, even though it's in the same playbook. Now we're going to switch to running against the local host, where we're actually going to use the AWS API once again. So we need those credentials, and we're going to use the Ec2 Ami module. And what this is going to do is it's going to read the instance ID, which we're going to populate in our files here in just a second. Again, especially for an AMI creation, if you don't have to wait for it to completely create the AMI, I'd recommend that you don't, because depending on how busy your account and or AWS is, I've seen this take up to 7 or 8 minutes to complete. But we're going to name it podcast demo, give it names and service names that we can refer to, and we're going to register all the output for that instance, which is going to be important to us because it'll give us the AMI that we can put in our info file that we can then change our variables to so that we can call it when we want to. So it's doing two different things. The first one to the node itself, it's preparing the node for us to make a copy of and use. So we're doing what we want to this particular web server. We're deploying our web server to it, and we could use Git, for example. We could use shell commands. We could copy other files. In this case, we're just copying a simple static index.html file, and then we're enabling and restarting the web service. And then we're using the API to take that instance ID and create an AMI or a template that we can use to create pre-configured instances from. So there's a couple of things that we want to do first. The first thing is we need to go grab this instance ID. Now, having said that, we could have done this all in one playbook, but it would have taken a lot longer to run the demo, where we created the instance inside the playbook, grabbed the instance ID from the output, and then written it into a variable that we use later in the playbook. In this case, the reason I separated this is I wanted to show you how we can also reuse the playbooks without having to rewrite them simply by changing a few variables around. So in here, we're going to go into Files, and we're going to edit info.yml. And then in this instance ID, this is actually the variable that contains the instance ID we're going to create our template from. And then the other item we need is we need this IP address that we'll add to our Etsy Ansible hosts. In this, we have a section called AWS that we can refer to. That way I can add, subtract, remove, change IPs, names, etc. on my configuration, and I can still refer to it in my playbook as an abstract AWS. Therefore, if my instances change, if my template names change, I only have to make a change in one file, but it can be reflected across multiple playbooks. Again, really it's a way to abstract our environment so that our changes that we have to make are in one place and you don't have to remember where everything's at. So if we cat out our demo provision, we're in the files directory. We've got a IP address in AWS, so we should be fine for connecting to AWS. We've got our SSH agent with our key already associated with the bash shell. So we're going to connect to our instance, and then we're going to install HTTPD, restart it, copying the file over there, and then we're going to create an AMI that we can then instantiate full web servers on that are already configured for us instead of having to constantly rerun more complex playbooks against multiple instances. So if we do an Ansible playbook on demo template.yml, our task is connecting to the AWS instance that was indicated in our host file, installing Apache, copying the index file, changing the local host, and all it means by changed is that it was able to accomplish the command. So Ansible indicates success by saying, I changed something. If you get a failure, it'll end up showing up in red and it'll give you an error message. If it says changed, as long as it doesn't have an error message in it, then the command was created successfully. Now, because I indicated I wanted the output from my instance, it tells me that I have an image ID now called AMI D3F015B3, and my AMI creation operation is complete, but the state is in pending. And that's because if I go over here to AMIs, if it's even showed up yet, it's still building the AMI because it's effectively cloning the instance that's currently running, which can take, depending on the size of your instance, a few minutes.
So if the changes are not, if it's already in the correct state, if HTTPD is already running, it's not going to attempt to restart it, correct?
That is correct. So if HTTP is running in some distributions, for example, like Ubuntu, if you install HTTP, it'll actually enable and start it for you as part of the apt-get process. But Yum doesn't do that automatically. So in that case, we're enabling it. And by saying restart it, it'll restart it even if it's already running, if we say restart it. But if it's not running, it will start it.
Very good. Just like it won't install HTTPD if it's already installed.
You got it.
Ansible's job is to make sure that the state matches, and if the state does not match, then make the correct changes to put it in the correct state, correct?
That's exactly right. So now, one of the things that we have, now that we have this AMI ID, all I need to do is copy this AMI ID, go back over here to my files directory, go to my info, .yml, and now I have this template ID. Now I have a template ID that I can refer to. So I have AMI ID, which is the one that I just created, so that if I were to instantiate an instance from it, I don't have to connect to that instance and rerun the part of the playbook that installs my website and my web service and does whatever else I need to it. That's done, and it's enabled, so it should start on boot. So I can instantiate a full web node, and then I could also use Ansible to either build an Elastic Load Balancer or to register an instance with that load balancer. Anything that you can do, for the most part, within your AWS console, you can do using a playbook in Ansible. And the reason that I did things this way is because now, without having to do a complex re-implementation of my provisioning, I can say copy demo provision.yml to demo web provision.yml, and I have to make one simple change. Web provision.yml. I change the instance, the standard AMI, to the variable name for my template AMI, which was template AMI. Now I have something that will deploy my web app. I don't have to completely re-implement my script. I changed one variable name, and now I can deploy web servers completely configured using the playbook that I had already written by changing one environment variable that's based upon a template, this AMI, rather than the AMI that I had defined from originally. So it's kind of a standard AMI I deployed. Then I made some changes, created a private AMI, something that is in my images directory that I can use, that's pre-configured. And then all I did was change one environment variable, and now I can deploy web servers by calling that playbook based upon this particular template.
So let me ask a question here, because this is really cool. So let's say that I'm a company, and my strategy for deploying out new code, right? We have code updates, it comes from Git repository, wherever you want to do it. So there's different ways of doing that. We can use agents that deploy it out. We can use services like Code Pipeline, whatever that AWS service name is. Been working with it, completely forgot the name. So let's say that my strategy here is continuous deployment, but instead of deploying updates from the Git repository, I instead use a strategy called baking an AMI, which means whenever the deployment goes through the pipeline, all my tests register, my unit tests are good, and it goes to deploy the code, it actually creates an instance, deploys a new version of the code, creates an AMI, and then updates maybe my auto-scaling group to deploy it out. Mm-hmm. So you can actually use Ansible to do that type of strategy through this.
You could, and in fact, if you take it one further, you could use Elastic Beanstalk if you were running items within a container. And Elastic Beanstalk actually lets you register your build process within it, so that if it detects a change that's published to the API, it automatically rebuilds all the instances in your cluster.
Very cool. Very cool.
That is really cool.
This kind of gives us just a taste of how we can take very complex AWS processes that require a lot of manual intervention typically. I mean, we can do everything that we did here through the Ec2 management console, deploy an instance, attach a security group to it, make sure that it's associated with the right keys, and then create an AMI from it, and then use that AMI to launch additional Ec2 instances. However, with these two playbooks that I can reuse in multiple ways, I now have taken that entire process, and you saw how quickly each of the scripts ran. It submits the job, and you can walk away and do other things.
That's fantastic. That's a great demo. I appreciate you sharing that with us. I do have a few questions, actually, as I feel like we're closing up. Are we missing anything on the demo?
No, those are the two demos I had prepared for today.
Fantastic. So the first question I know a lot of people in the audience will be asking is will the playbook for the demos be made available for download where this podcast is? So it'll be posted on the linuxacademy.com blog. Will the playbooks be made available for download there?
These are similar to playbooks that we cover in our Ansible AWS course. All the playbooks and all the Ansible and AWS courses at Linux Academy are available for your reference and for downloading, because we take all of the modules and we actually build a playbook in each video where we talk about a module and exactly how to do it and give you an example. And then you can have a reference playbook for that. And then we also talk about how to stitch together these various modules so that they can be interdependent. We also make those playbooks available as well.
Fantastic.
If people aren't familiar with Linux Academy, then we do have hands-on server labs. So you're not only going to see Terry doing this on screen in the videos, but then you turn around and you boot up your own machine and you practice as you see it. So it's not just, you memorize whatever Terry's doing on the video. You're actually following along side by side and doing it with him.
It'll work on our Linux Academy lab servers, because that's what I'm doing this demo on, and that's what I do when I record all of the courses, is we use our Linux Academy lab servers. So it's the exact same environment you have access to.
That's fantastic. And so for what about those who are looking to learn Ansible and learn hands-on? Is that something that...
So we have what I would say is a very comprehensive Ansible course here on Linux Academy. I'm also the instructor there. So we cover Ansible from how do I install it, where do I get it, to how do I configure it, what do all of the individual tags mean, how do I build a basic playbook, and we cover all of the core major modules, which I believe at last count was 70-some. And then we cover in the AWS course through Ansible, we cover the additional 30 or so core AWS modules there as well, all with playbook examples in each one where we walk through it.
That's fantastic. So what we have here is Terry, Instructor Terry, who came on to our very first episode of Cloud Cadet. Our goal is to take some of the how-tos that we're working on at part of the Linux Academy, make them available for external students, people who are looking to see how to use Ansible and AWS, or how the technologies work together. And here's an opportunity to actually listen and learn a little bit from Instructor Terry and find out what he's working on as well. And so we're very excited at some of the other episodes we have coming that Terry's also going to be doing. I believe we're going to be having one on actual learning Ansible, kind of a lot like today, but more focused on Ansible itself. And then I believe we have two others coming shortly, Terry, with Elastic Beanstalk and Docker and Elastic Container Service, both of which courses you just published on linuxacademy.com. Is that correct?
Yes, absolutely. And I just referenced how we could work with EB in addition to using Ansible for our environment as well.
Fantastic. Well, I appreciate you coming on. Christoph, do you have any questions?
No, I'm just excited to go ahead and give this course a shot. I've done some work with Chef before. I never really touched Ansible, but I've heard a lot about it. So this really inspired me to try it out. Thanks a lot, Terry.
No problem at all.
Yeah, the cool thing about Ansible is it's agentless. So when you look at Chef and Puppet, it's going to run an agent every 30 minutes or however long that checks configuration changes. Whereas with Ansible, it's run via SSH, and you're not using resources, because those agents can get very expensive in resources. And so it's a really, really cool up-and-coming technology. So I think that concludes it for the first episode of Cloud Cadet. Thanks for working with us, and we look forward to seeing you on the next ones.
Thanks, everybody. Good luck.
Thanks.